Okay, this is the second video in the algebra series. And so the last video we just kind of used some general algebra with some pure math problems. Now let's go ahead and show you how you might solve a real chemistry problem. And we'll just do one example so you kind of get a sense. So we're going to be using the ideal gas law equation. And so if you've never seen it before, this is what it looks like, okay? And so this is the pressure, this is the volume, this is the number of moles, this is a constant, and then this is temperature. And so let's go ahead and use the following. Let's assume we have 13.7 grams of Cl2. Let's say 45 degrees Celsius, and let's say pressure is this. Okay, so that's kind of our what we're given in the problem, and we want to know what the volume is equal to. Okay, how much volume the gas is taking up. This chlorine is a gas here that I should have written that, sorry. So gas. So we want to know the volume that the gas takes up. So first off, with a lot of these problems that you'll see is that we are going to have to convert the units into the standard versions, okay? So let's go ahead and start off with the pressure. So pressure here is 745. Okay? And we need to put that into atmospheres. You'll learn when you learn how to use this problem how this goes. But just take my word for it for now. We need to first convert it into atmospheres. And so, just like we did last chapter, we would use a conversion factor. And you'll learn this in Gen Chem, this conversion factor. And so that gives us 0.980 atmospheres. Okay, so there's our pressure. So we know this guy now. Alright, now let's go ahead and work with the moles. So we know 13.7 grams of Cl2. Well, last chapter we learned all about converting grams into moles. So you would find the molar mass of Cl2 just like we did in the last chapter. Grams of Cl2, that's its molar mass. That ends up giving you 9.3 mole of Cl2. Okay? So we know this variable now. Alright? R is just a given. Okay, just the constant. So we know this guy. And then temperature is 45 degrees Celsius. We need that to be in Kelvin. And so to go from Celsius to Kelvin, you add 273. And you'll learn that in Gen Chem as well. To get 318 K. And so we know temperature. Okay? So you'll see for a lot of these chemistry problems, that's kind of your first step, is getting everything in the right units so that you can just plug it in and use algebra to solve everything. Alright? So now that we know all of these constants, or all these variables, let's go ahead and plug into the equation. So we have PV equals nRT, and we know everything besides the V. We want to solve for V. So the V is kind of like the X in our last video, right? That's what we're solving for. That's what we want it to be all by itself. So let's go ahead and get V by itself. So we need to divide this by P. And we know we have to do that to this side as well, right? So P divided by P is just 1. 1 times V is just V, is equal to nRT over P. And then it's just a matter of taking each one of these values over here, plugging them into here and then just solving the math. So for instance, for the n we would have 0.193. For the r we'd have 0.08206. For the t we'd have 318. And for the p we'd have 0.980. Okay? And when you just solve that, just put it in the calculator and solve it, you get 5.14 liters as your volume. So that's kind of how you generally use algebra. You can see it really wasn't that difficult. Really, it's just kind of combining what we learned last chapter, where we learned how to convert things. You can see this one problem required you to do 3 unit conversions. And so you'll have to do that all the time, which is why I stressed that so much last chapter. And then it's just taking a rather simple equation and just solving for one of the variables that you don't know, like we did here, and then just plugging in everything, and then just solving the math to get the answer. So that's kind of a general example of things you might be doing in Gen Chem, just with different equations and different values. So I'll have one more video actually where I talk about the mass percent concept. So thank you.